hoping this works. So we'll continue working on talking about loops and functions and all of that. All right. So here, another useful condition or useful conditional that you can use is the if-else. It combines if and else together into just kind of one thing. And so you can normally write if x is 5, then command out have n become yes, and otherwise have n become no. You can reduce it to one line like this: if else x equal 5, yes, no, something like that. Okay, and then you put that the result of the if else will be the yes and the no, and then then you assign that to the no here. Okay, so that's just kind of a quick shortcut here. All right, let's talk about for loops. Okay, there will be many times where you'll have to use a loop of some kind. A lot of times we can avoid loops by using vectorized operations. For example, this whole thing we could just do 1 through 10, power 2. But here, you're probably used to creating loops like this. You say for, and then you say x in 1 through 10. Okay, 1 colon 10, and then here it's going to just cat x squared. Okay. And so then it goes 1, 4, 9, 16, 25, 36, and so on and so forth. Okay, we don't actually have to write a loop this way. Let me just show you that as far as loops go, loops are fairly inefficient. If you can write things vectorized, you're probably better off that way. But so I could write 1 through 10 squared, and then that gives me the exact same thing. And this operation is much faster than writing the loop. But the loop is totally legit and is fine as well. Okay, so we can do this. All right. So you can give it any kind of vector, including a list, and it'll iterate through the elements in that vector. So most commonly we give it a vector of integers that we just kind of say like 1 through 100 or 1 through 1,000 or something like that. But you can give it, the vector that you give it could be a list. So here I have L is a list. I have 3 things, 1 through 3 letters, 1 through 7, and then a true false thing. Okay, and then here I'm asking it to cat the length of y. So it's saying for y in L. So what is this going to output? Anything? It'll output 3 and then 7 and then 2, right? Because the first thing, because if we look at the structure of L, it'll say list of 3 things, and then it'll say the first thing will be a vector of length 3, the second will be a vector of length 7, and then this last thing will be a vector of length 2. Okay. All right. Okay, so you can load up something called data sets. It's a built-in library. And
What's the second argument for
cat? So it's like cat this with this. Okay. The default separator is a space. So I could have just done cat with nothing. Cat is just kind of like, this is just an empty space. So it's cat this with an empty space here. Okay. All right. Over here, I'm loading up some state names. Okay, so the first 5 states alphabetical would be Alabama, Alaska, Arizona, Arkansas, and California. Okay, and then we could put this into a loop, right? I could say for a state in state name 1 through 5, and it's going to say state has number of characters, letters in it. Okay. And then a new line symbol, and so this will output Alabama has 7, Alaska has 6, Arizona has 7, something like that. Okay. And so we're often used to giving it like 1 through 10, but Doesn't always have to be that way. Okay, as far as for loops go, you can give it any kind of vector. A lot of time as you're building loops, you're going to want to keep track of the outputs. All right, and so when you're trying to figure out a place to store it or whatever, it's best to create that object in its entirety, and then you assign the values that way, right? So here I'm creating a vector called res for results, all right? And here I'm going to just create a bunch of NAs, 10 NAs. And then I run the loop, and in this loop I'm assigning the results in position 1 through 10, or position x, to the value x squared, okay? Or the value x squared I'm assigning to position, 1 through 10 here, okay? And then we get this, okay? So this is probably the way to go, is to create your results vector. This, sometimes people do this. This, I would say, is not a good way, all right? Here we're creating an empty vector called results, and then we are combining the current vector with the new result, and then we're tacking that on and storing it in results, okay? And so as far as computational efficiency, this is going to be clunky, because each iteration you're copying the vector and you're appending something onto it and then storing it. Was there a question?
Except for the initial length, is that equivalent to assigning null to it? And would you also not want to do that?
Yeah, you don't want to assign null. You want to assign. You can assign 0 or whatever if you're going to rewrite all of these things. You want to create the thing first, though, so you don't have to constantly resize or create copies of that vector. Okay. When you're doing 10 iterations, it's going to make 0 difference. But if you're going to do like 1,000, like 10,000 or 1,000,000, you'll see the difference in computation time. Okay. And then this is also bad if you just say results is 0, and here we're assigning them, and this requires the vector to be resized each time. Okay, and that's it's going to be less than optimal to do that. Okay. Are there any questions on this, or are we okay? All right, and of course. I guess if we're talking about efficiency, the most ideal would be to avoid writing a loop in the first place, if you can. If you can avoid writing a loop, then and do it in a vectorized form, or doing some kind of outer multiplication or something, then that's going to be the best. Yeah.
Do loops work on multiple vectors at one time? Is that just multiple objects?
What do you mean by do loops work on multiple vectors?
Operate on like 10 vectors, can you use a loop? Or would you have to be working with Flash?
You can only do one vector at a time. I guess you can combine all of those vectors together. But yeah, if you want to do something on multiple vectors, you'll have to use an apply. Yeah. Okay. We have other loops. We have while loops, and this is while loops are useful if you don't have like a predefined end. I mean, if you don't know how many iterations it will take to reach the end. Okay, so you have an ending criterion, and then you take however many iterations it takes to get there. Okay, so in this case, these are just silly examples, but we've created our results vector, and we're saying, well, I is less than or equal to 10. Put this in the results, and then increment I to +1. Okay. But perhaps you have, like later on when we're doing numerical methods, and you want to keep repeating a process until you've honed in on 0, okay? And And the thing is that when you do these types of things, you're probably not going to get 0 exactly. But you might want to say, like, keep repeating until we get fairly close to 0. And you might say fairly close to 0 is, you know, the difference between 0 and this thing is, you know, less than, you know, 10 to the minus 5 or something like that, okay? And then so your while condition would be like while your epsilon is greater than 10 to the minus 5, keep going, and then, you know, recalculate until, recalculate and then update whatever your epsilon is. And then finally, when it evaluates that epsilon is less than 10 to the negative 5, then it'll stop, okay? Because a lot of times you don't know, is it going to take 10 iterations to get there? Is it going to take 100? So you can't do a for loop, because a for is going to do an iteration until it reaches the end of the vector, and you might say, and that's useful to say, like, do 20 iterations of this. But while loops are useful if you don't know exactly how many iterations it will take.
What is that last line with I just like to I plus 1 mean?
This means, so we start with I is 1, okay? When it reaches down here, so it's going to say, so it's going to first, so we start with I is 1 and goes, is 1 less than 10? Yes. So now it's going to run this code. The results in position 1 will be 1 squared. And then now I is going to be 1 plus 1. So I is now 2. It goes through the loop. Is 2 less than 10? Yes, it runs through it, okay? Finally, I is 10, okay? We put results in the 10th vector will be 10 squared, 100. And then it will say the new I is going to be 10 plus 1, 11. Okay? It gets to 11. It goes back to the top of the loop. And they say, is 11 less than or equal to 10? No. And then, so it stops. And then it prints out the results, and we get 1 through 10 squared. Okay. Repeat is like while, except you put the condition somewhere inside the loop, okay? So repeat, just whatever's inside the bracket for repeat, it's going to keep running until it reaches break, okay? And so break is going to kick out of the loop. And so the only way you kick out of the loop is when this if condition is evaluated true, okay? Because it's going to run, it's going to say, okay, we're starting with I is 1, 1 squared, 1 plus 1, okay? And it keeps going, and it's going to go, is this true? No. And so it skips over the break, right? Okay, it keeps going, and then finally, when you have 10, okay, then I becomes 11, and then if 11 is greater than 10, that's true, then it evaluates the break and it kicks out. Okay, yeah, question?
In nested loops, will break pull you out of everything, or just like the nearest one?
Break will break out of the lowest loop, I believe. Let me, I have it written, I'm pretty sure break only breaks out of the innermost loop, okay? Yeah. Ah, yes, right here. So break ends the current innermost loop, so if you have nested loops, it'll break out of the innermost loop, okay? And then next ends the current iteration, okay? So here it says for I in 1 through 10, and then it says if I mod 2 is 0, meaning if I is even, then break, okay? And so in this case, we come in, we run it for 1, and so it skips over this line, and it does cat 1, okay? And then now that that's done, it goes to the second thing in the for loop. It goes to 2, and then it says, oh, 2 is divisible by 2, so it's going to evaluate the break, and then it stops. Okay. Over here, rather than writing break, which kicks out of the loop entirely, when it hits next, it skips over the rest of the code and then goes to the next iteration of the loop immediately. Okay, so if it's for I in 1 through 10, it's going to do the 1. When it gets to the 2, it says, oh, next. We're going to go straight to the next loop. And it doesn't evaluate the stuff below it. Okay? And then so it skips the even numbers and you get 1, 3, 5, 7, 9. All right. So you have break and you have next. Okay. All right. So it says often we want to use a loop to go across the indices or indexes of an object and not the elements themselves. And to help you do that, you can use sequence or sequence along or sequence length. Okay. And so sequence along. So just so we can see what this is doing. So here's my, so I've got L, right? This is, if we look at L, it'll say list of 3, okay? Sequence along, we'll just go 1, 2, 3. So it's basically, sequence along is kind of like 1 through length of whatever the thing is that you're looking at, okay? So if I wanted to do, if I did sequence along letters, what will this produce? Oops. It'll produce 1 through 26. Okay, so effectively it's just doing, length of letters, which is 26, and then it's doing 1 through length of letters. Okay. So that's sequence along, and then so if we wanted to get the length of each thing, we would say okay, sequence along L. And then do L double bracket X, okay, for X and sequence along. So this is now 1, 2, 3, and we want the length of L double bracket X, and that will be 3, 7, 2, okay? So these are all effectively the same, right? Sequence length. Oops. Sequence of length 26 is basically the same thing, right? So all of these are kind of equivalent. All right. So yeah, pretty much everything we can do either subsetting or using some kind of apply function. There's almost always going to be multiple ways to do the same thing, all right? So generally, the best initial solution is the one that you can get working correctly and the fastest. And then once you get it working, then you can start worrying about making it optimal, okay? And it is a good idea to try to think of how to optimize your code, how to make it run more efficiently. But sometimes, in general, the most time-consuming part is the programming, okay? And so if it's not too hard to ask the computer to do things in a slightly it's okay to have the computer do things in an inefficient way, all right? Maybe later on when you're looking back at your code, you'll cringe at how poorly written your code is, but if it works, it works, right? If you can get it working in an optimal way, that's the best. But at this point, I don't think any of you will become or at this point right now, you are not going to be, probably package contributors, so you don't have to worry about efficiency. Okay, when you start, after hundreds of hours of programming and you start feeling more comfortable, then you can start thinking about being a contributor, and then you'll have to worry about your optimizing your stuff to run well, and catch all of the mistakes and errors and all of that. But at this point, we're not going to worry about that. Okay, let's talk about functions. All right, so functions, super important in that anytime you're going to have to do the same task over and over again, it probably makes sense to turn whatever bit of code that you're doing into a function that you can call whenever you need to. Okay, and functions are always in the form. Okay, you're gonna have the name of the function, and you're gonna say that function. I'm gonna call it. You say function, and then you have a list of arguments in parentheses, and then you put in curly braces all the code that you want to run, okay? And then the last thing of your function should be kind of a return line, okay? And you don't have to explicitly state the return, but the result of the function will be the output there, okay? Because when you run a function, it kind of runs in its own little world, and the only way you get the function to interact with the outside world is through the returned object, okay? All right, so let's see, okay? If the function only has one line, then the curly braces can be left off, and if return is not used, then the value returned is the last expression in the function, okay? So here we're going to, and then in R, functions are objects, and so you can use them like any other object, okay? So here we can say f is a function of x, and what it's going to do is it's going to do x times x, okay? And that's all we've done. And then once we do that, if we say, okay, we want to throw f into a list, it has no problem doing that. Okay, we can throw a function into a list just like you can throw a vector of things into a list. It'll fit right inside that train car. Okay, and then if you ask R what is the type of a function, it'll say closure. All right. Here, let's go along here. Okay, so here I've defined a function f, and then if we wanted to run the function, I can say f of 3, and it will do 3 times 3, and it'll return 9. Okay. I'm sorry? If it's just one line, you don't need curly braces, and if it's only one line, and if you don't use the return, so generally, you might want to throw return somewhere in your function. If you don't, it will just return whatever the last line is. Okay?
What's
Closure, this is the way R sees functions. When you ask, what is this thing? What is the type of? It will say it's a closure. Okay, that's just the way it sees what a function is. Okay. All right. So here's a. Okay.
Professor?
Yes.
Is the closure only applied? Is that like only for functions, or is like any other object?
Bryce, what does anything else return closures? Look that up.
So all I know about closures right now is that it's like really important for why R is like so useful. So the dplyr package it is like really useful because of the fact that R implements functions as closures. So you don't need to know what a closure is. It's like a computer science topic. Just know that it's important, and if you want to Wikipedia it, go for it.
But yeah, as far as what else is a closure, I don't know off the top of my head. I just know functions are closures, and yeah, that's how it works. But it is amazing because like functions can return other functions. Okay, so here, like, look at this craziness, right? Okay, so f2, so f2 is a function of x, which itself will be a function of y, right? So if we ask what f is, right, it'll say it's a function of x, and this is what it is. Okay. If I ask what f2 is, it'll say, oh, it's a function of x, which is a function of y, right? All right. So if I say f2 1, okay. Now we have a function of y where it's x plus y. Okay, so I can create something called add 1, okay, and this will be f2, 1, right? Okay, so what is add 1? Add 1 is a function where I'm basically taking x plus y, and what and notice it says this environment thing, right? So I can do add 1 to 4, and it will say, oh yeah, that's 5. Okay. I can create f2, again, it's a function, so I can create a new function called add 3. Add 3 is going to be f2 of 3, okay? And what is add 3? It's another function. It's a function of y now, okay? And then so I can do add 3 to 6, and it will return 9, okay? So I've created, f2 is kind of like the add whatever you want to something. So so the results of f2 is a function itself, okay? And then so if you wanted to do f2, 1, this here is a function where it's going to add 1 to whatever it is, okay? And then this here, we're going to say, okay, we're going to add 1 to 1, and it will give back 2. Does this make sense? Did I just confuse all of you? Okay, it makes sense. So you can here effectively I can put this inside a curly brace, right? And maybe this will make it more clear what's going on. Okay, f2 is a function of x. Okay, what is f2 going to return? It's going to return a function of y where we have added x to y. Okay, and then so the outputs of f2 can now be we can call this add 1, and then I can do add 1 to 7, right? Or you know, whatever you want to it. Okay. So the result of f2 is a new function where I've added 1 to it. Okay. All right. Yes. Question.
Another way to call that function, or does it have to be like
What, parentheses and parentheses?
yeah, is there another way to call it, or does it be like call it with the like
I'm not sure if I fully understand. Like, what do you want me to?
like to call the function actually, but for in parentheses and line parentheses, is there another way to call it? Like, or is there another way to put the arguments in?
So, all I'm. Well, again, I'm sorry. I don't know if I fully understand your question. All I'm saying is that f2 itself is a function of x. The thing that this function of x returns is a new function, which is a function of y. Okay, so so we're just saying functions can return other functions. Okay, and this is something you can take advantage of at some point. Most likely, probably not at this class level, but it is something that exists. Okay. Yes.
So in that code, the 236 row, F241, so the 4 is the x and the 1 is the y.
Yeah. So you have to think of f2 of 4 is a function itself of y, where now it's going to add some value x to this thing of y. Okay? Yeah.
How can the function of x return its own function?
What do you...
So that you could do like recursive programming where the function returns itself?
I don't think you'd want to do recursive programming that way. In recursive programming, you are calling itself inside the function itself, okay? Which is a little bit different. So you're not calling it. Here, the result of this function is a separate function. So f2 is like a function creator, okay? Right here, f2 is a function creator in that the thing that it returns, most often we're used to running a function, it returns a result. It returns a list. It returns something, okay? Here, f2 is a function creator in that when you run it, what it returns is a new function, okay? Recursive programming is different in that when you run the function, it calls itself, okay? Calling itself is different from returning itself. I don't know. Okay.
It doesn't come up very often.
Yeah, you know.
Just passing functions as inputs, that's like where closure comes up. In most languages, you can't pass a function as input to another function.
Yeah, so like with R, you have these apply family of functions where one of the arguments that you're giving the apply family is an actual another function, right? And then it will say like, oh, here's this thing, and now I'm going to apply this function to this other thing, right? Where, yeah, in a lot of other languages you can't do stuff like that. You can't give it the verbs only take nouns as objects, whereas here we're giving the verb to be a, you know. All right, okay. maybe I needlessly went into this thing that maybe I shouldn't have called it under function basics. All right, so return values. Okay, so anyway, you can explicitly say like, oh, okay, the thing that it's going to return is the result x times x, okay? A lot of times you look at code, they don't have this return thing in there, and that's fine, okay? Because it's going to say the last statement that it evaluates is going to be the thing that gets returned, okay? So these two things are equivalent in terms of what they do. All right, you can return multiple values, right? You can just group things together into a vector, right? And this will return this vector of x squared, x cubed, right? So we can say if we run f on 2, it's going to return, 2, 4, and 8, okay? And if I put in 3, it would be 3, 9, 27, okay? Or if you want to be more explicit about having all of these things, you can create a list where you've named all of these things. And then we say, okay, run f of 2, and it returns a list where x was 2, the square is 4, and the cube is 8. And you know, a lot of the functions that are already implemented in R, like if you say, give me a linear model of something, the results of that linear model are a list, okay? And maybe it's maybe they're using classes to kind of give it special things so that when it prints out the results, it gets printed in a special way. But effectively, it's a list with just some extra attributes. So if there's like multiple things that you want returned, you've got to put them all together in a list, okay? Otherwise, those things just get lost. And then when you do something like that, you can throw in like the values 2, 3, 4, and it will calculate the squares and the cubes for you. Okay, and it's still returning a list, and now we have vector results in each list component. All right, so when we define a function, we're also implicitly defining names for the arguments. And then when calling the functions, we can use these names to enter arguments in a different order, right? So I think we're accustomed to seeing stuff like this, right? We have a function x, y, and z, all right? And then when we run the function, this function is just basically saying x is equal to this, y is equal to this, and z is equal to this, all right? So if we say function is f is 1, 2, and 3, it's going to return f of x is 1, y is 2, and z is 3, okay? We can explicitly say, when we call the function, we can say z is equal to 1, x is 2, and y is 3, and then it will output that, okay? Whereas if you, over here, we didn't explicitly say which value is which, it's going to assume that it's getting the values in the order that the function is written in, okay? And then here we said y is 2, so then it assumes this is going to be the x and this is going to be the z, okay? Because those are the ones in the order that it's defined in. And then so here we have this. And then if you try to give it a function, an argument that it doesn't use, it's gonna complain, right? And we've probably run into this problem when we're trying to ask R to do something, and we give it an argument, and it's like, that's not the name of the argument that I want. Okay. You can also give it default values for arguments, right? You just define these in the function, and these are now default values, so that when you run the function without any arguments given to it, it's going to run this, right? So if you ask, so you're probably familiar with the p-norm function, like the normal probability. The default arguments there is that the mean is equal to 0 and the standard deviation is equal to 1. So if you say p-norm 0, it's going to give you 0.5, right? But then you can further specify and say, oh no, now I want the mean to equal something else and the standard deviation equals something else. But if you don't supply those, then it's going to just assume each of those things. So here, I just gave it the value 2, okay? So now, because the arguments are in x, y, z, it's going to assume that the 2 goes to the x right here, and then it takes the default values for y and z, okay? And then if you want something else, you say z is equal to 3, and so it does that, and then it assumes the default values for x and y. Yeah?
So, let's say you, for the arguments, just type in like comma 2 comma, so y equals 2, but it does x and z equals
No, it'll get mad that you're giving it, like it won't accept that because you're giving it basically nothing for the argument. So if you don't have to, you can't put in comma, comma, comma space comma to say like put in the thing. Just leave that argument out, okay? And then just define the ones that you want to define. Okay. All right, scope. This is the other thing that happens with R that maybe people aren't used to. Okay. So here, I've defined f as a function of x, okay? And inside this function, I'm referencing something called y, all right? And so when I call f of 3, it's going to plug in 3, and it's going to try to do 3 plus y. And when the function runs, it's going to say, I don't know what y is, okay? And so it starts off inside the scope of the function. Generally, you run the function, and it's kind of like this own little sandbox, and it's going to try to look for things inside that little box, okay, or that closure. It doesn't find it, so it goes to the next higher scope, and it says, y is equal to 1 up here. I'm going to use that, and I'm going to print out 4. Okay, it's going to do 3 plus 1. Okay. However, if it finds it in its own little sandbox, it's going to use that value. So over here, g is a function of x. Inside that function, y is defined as 2, and what it's going to return is going to be x plus y. So we say, give me g of 3, okay? It's going to plug in 3 for x, and it's going to say 3 plus y, and it goes, oh, what's y? Oh, y is 2, and it's going to spit out 5, okay? It found it inside its own little closure, its own little scope. It's not going to go to the scope up here. Right? And if we looked at the environment here, this y is unaffected, okay? Even though I said y is now equal to 2, this only exists inside the function. It doesn't affect the y out here, okay? It only affects what's inside this scope here. So maybe I can show you guys that, or we might run out of time. So I'm going to clear everything out. Okay, so here I'm defining y. I've got g. I run g of 3, and you'll notice the y is unaffected. Y is still 1. Okay? All right, so more on scope. So variables defined within a scope, okay, or we can think of inside that function, exist only in that scope and only for the duration of that scope. So If variables exist with the same name outside the scope, they are separate and do not interact with those variables out there. So even though we created a new y inside that function, it has nothing to do with the y out there, okay? And so you can think of a function or a scope as its own little like sandbox, its own little thing, and the only way it communicates to the global world outside is through its arguments that come into it and the return value that goes out. Everything else, okay, if you don't have it as part of a return, it gets lost, okay? It just dies as soon as the function finishes running. So if you don't have anything set, if you might have defined all of these things that you're keeping track of inside the function, but if they're not part of what you're returning, it just dies. It's like the sandbox gets vaporized and that's it, okay? And so, you know, if, for example, you ran remove everything inside the list, okay, this is like how you clear your workspace, right? If you ran this inside a function, which you shouldn't do anyway, it only deletes the stuff inside that function, inside the function itself, okay? It doesn't touch anything in the global environment, okay? The only way you can touch things in the global environment inside a function without it being through the return value is through the super assignment, okay, which is the double arrow, double assignment, okay? All right, so here I've got x is 1, y is 1, z is 1. And here I'm defining a function inside the function and we're returning the result of this thing, okay? So f is a function and all we're doing is inside this function we're defining y as 2 and then we're creating a new function called g, all right? And g defines z as 3 and the result of g returns x plus y plus z, okay? And that kicks out and then f itself returns the result of g, okay? So when we run f, it's going to return 6 because it takes the z, this 3, it takes this y 2, it's looking for the x, so it goes to the highest scope, which is 1, okay? So the z it finds in this scope, it doesn't find the y, so it goes to the next higher scope, it takes that 2. And then it looks for the x, it doesn't find it in any of these scopes, so it goes to the global one, okay? However, and if I say cat x, y, and z, x, y, and z are still 1, 1, 1 in the global environment, okay? What happened inside the function and inside the inner function does not affect what's going on in the global environment. They only exist inside that sandbox, yeah. I'm sorry, what? Can you return the value? Can it return the parameters? Yeah. If I said return what was the x that you wanted, yeah, you'd have to put that into your thing of things to return though. Okay. Okay, over here I have x, y, and z, and I've done a super assignment on the y and a super assignment on the z. Okay, and so so here it's looking for the y in the parent and it finds it here. Okay, here it's looking for z in the parent scope, it doesn't find it, and it keeps climbing until it reaches the top. Okay, and then so here I've got this, this, and this, and it returns, if I run that, it's going to return 6, but then I forgot to show you what x, y, and z are now. Okay, so let's run this. Let me actually remove. Okay, so if I run f, it returns 6, and you can see that the values x, y, and z have changed to 1, 2, and 3 after the results of the super assignment. Okay. Over here, I'm going to reset x, y, and z to 1. Okay. Here I'm defining y as 2 inside the function, and I'm going to do a super assignment y is 4. Okay. But this assigns the 4 directly to the higher scope. It doesn't even, it skips over this one. The super assignment doesn't look at the current scope. Super assignment goes directly to the higher scope. Okay, we're going to assign this g is 3 over here, and we run this function. Okay, and then so the z3 goes to the higher scope, and then the y4 goes to the higher scope. Okay, But notice the result of f is 6. The result of f is 6. It's not 8, as we might expect, because when it's running this thing, it goes to the immediately higher scope, and it finds a 2. So it's going to get 1, 2, 3, whereas this super assignment goes to the higher level of 4. Okay.
Question?
Yes.
Does it only change the values if you run the function?
Yeah, only if you run the function, right? Of course, if you don't run the function, those super assignment commands don't get run, right? So it's not like as soon as you type it into the code, it goes poof, and the super assignment runs through. It's only when you run those commands by running that function, right? The super assignment commands only existed inside that function, and so only when you run that function, okay? All right, make sure you get your homework turned in, and we'll see you guys on Friday.